Hello friends. So this week we continue our discussion by Dr. Praful Dikshit on the underlying concepts of p-value and null hypothesis significance testing. Let us reiterate that while the purpose of this series is to understand the importance of significance testing as against its limitations and drawbacks, we are first trying to establish the basic concept of p-value and significance in very simple terms. Along the way, we are addressing the underlying concepts very briefly and simply, to gain a richer understanding of the topic. Now over to Dr. Praful Dikshit.
Hi there, this is Dr. Praful Dikshit, and in the last video we posed a question to you, and the question was, why is it that the sample drawn might represent the variable attributes drawn by chance and not represent its true characteristics? So now I'm sure most of you might have thought about the answers, and you might have come up with your own solutions or thought about the answers, and I'm sure most of you might be correct in your own ways, and I would like you to just refresh those answers in your memory, and then let's move ahead, because they'll be useful in understanding things. However, let me answer this to you in a very creative and simple manner. Okay, so when we say something happens by chance, it means that there is a very little probability of that something happening. And if drawing a representative sample from the population is our something thing, then it means that there is a very little probability of drawing a representative sample from that population. And talking about probability, a probability can be measured in terms of how many out of total times an act or an event is repeated would the desired outcome be obtained. Okay, and in this case, the probability of drawing a representative sample will be the number of times a representative sample or the same sample is drawn from a population. Now, it depends upon how controlled the process of drawing the sample is, and also it depends upon how variable the population is. So the process, the control over the process of drawing the sample, the method the method that is being followed for drawing the sample, and most importantly, the variability of the population is responsible for the variability in drawing the sample. Variability or uniformity, it's both ways. So now, even if we draw a random sample of say 5 members, so we have an example here, this is a population, and we draw a random sample of 5 members. Okay, and does it look representative to you? It does to me, because say we have one each from this strata, and one each from these guys, and over here we have 2 from these guys, because these are obviously more in number, right? So this is a representative sample. So now, even if we draw a random sample, so we've drawn a random sample, which is by far the best method of sampling, and we managed to get a truly representative sample by exactly following a random sampling method, and we assume that our situation allowed us to draw a random sample, which is slightly unlikely in real situations. So what is the chance that it will also be a representative the next time? So let's see what happens. Okay, so we move this a bit forward, and okay, we get a representative sample exactly like the first one the second time. Okay, let's move ahead a bit. Even the next time we get a representative sample. So ideally we would want it to look something like this, whatever we have seen so far, however, is it true in real situations as well? Does it apply to real situations? Are we so fortunate? Let's see. So what really happens is we, in order to represent the reality, we need to tweak this a little bit, and probably we won't get something like this, but we might get something like this if the variability is there, slightly variable, if the method is not as perfect as we would want it to be, or maybe slightly more variable if there is more variability. And same thing will happen to the third sample, and finally we'll get something that looks like this. So the first sample is different from, the second sample is different from the first sample, and the third sample is different from the second sample. Although the first sample is quite representative of the population, but every other time we are getting a different sample. You see what is happening here? So, you know, um, so if we draw a fourth sample, or maybe a fifth sample, or a sixth sample, and so on and so forth, the sample is likely to be different from the representative sample or the ideal sample. I mean, if we consider this is an ideal sample, the second, third, fourth, fifth sample are likely to be different from the first sample, and obviously from the population, in terms of representativeness. And the source of this variability in these samples is obviously the variability in the population, and of course the sampling method. Okay, but yes, more importantly, the variability in the population. Okay, so so we can say that if we draw a random sample from a highly variable population, the next sample drawn is not likely to be representative, or in other words, it is what you say is likely to be drawn by chance. That is, if we are unable to sufficiently control and refine our process of choosing the sample, then what we get is something that is just happened, that something that just happened by chance. Okay, and okay, now here's the tipping point. Now let's contrast this with a hypothetically uniform population. Okay, as you can see here, this is a uniform population, and if we draw the first sample from it, it will obviously be a representative sample, a sample of 5 members from this population. It looks representative. It is representative. And let's see if we move ahead here in this video. Okay, we draw a second sample. It is again same. It is representative. And if we draw a third sample, it is going to be same. And if we draw a fourth, fifth, sixth, seventh, or the nth sample, they will also be similar, and they will also be representative. So we conclude that to the extent there is a variability in the population, and the samples drawn from the population might be just by chance, and the extent of such a chance is dependent upon how much or how less control we exercise on the sampling, the method of sampling that we follow, and of course the suitability of the sampling method and the extent of variability in the population. Okay. Now the same thing can also be seen in this figure, which shows the population and samples in terms of their frequency distributions. Now the frequency distribution is actually a better representation of the populations and of the similarity between the population and the sample, and between different populations. As we can see here, the population is normally distributed, yet it is variable, which is clear from these bars, which have different heights, and they represent different different distributions of different members of the population having different measures on a particular attribute being measured. And obviously when we draw samples from this population, due to the variability in this population, and obviously due to the method of sampling or the lack of control we have on sampling methods, the possible outcomes would look something like this, and maybe the next time like this, or the third time like this, and so on and so forth. So basically, it is quite clear, and we've seen the successful samples are going to be different due to the variability. So when we talk about the chance, okay, so there is a chance of drawing non-representative samples from the population, okay. These are non-representative samples, so there is a chance to it, okay. There is a probability of this drawing this non-representative sample from the population. So when this chance is very high, and which depends upon the variability and the sampling method, due to high variability in the poor sampling, we say that the sample drawn is just by chance. And when this chance is very low, we can say that the sample drawn is very representative, and this chance is measured in probability terms. And when it is measured in probability terms, it is called the p-value. Voila. Okay. So we can say that fundamentally it is due to the variability in a population that the sample drawn might be close to or different from the population characteristics on the same variables by chance. And if there were no variability in a population, there would be no possibility of a chance finding, and therefore there would be no need for significance testing and p-value. Furthermore, this probability of drawing a sample which has the characteristics of variables or attributes being measured which are not drawn by chance but represent actual characteristics of a population is called statistical significance. All right. And this probability or statistical significance is measured in terms of what is known as the p-value. So it is for the first time in this series that we have actually explicitly expressed what a p-value is. Now there is something called significant tests. I mean, there are tests of significance for any given study in terms of their results, right? The results are either significant or non-significant, and there are tests to determine whether the results are significant. So the significant tests are designed so as to offer an objective measure to inform decisions about the validity of generalizing the results from a sample to its population, sample to its population. For example, it is possible to find say maybe a negative relationship between the students of social media and their math scores in high school. However, more information is needed to show that the result is not simply due to chance, but that it is statistically significant. So we have two important concepts regarding the results of a given study. So one is the measure of the results, and second is the importance of the results. We can express these two in terms of the effect size and the p-value. So now we are almost towards the end of this session, and we have a question for this session. And the question is, if p-value denotes or measures the statistical significance of the results, what does effect size or relationship size measure? And we leave it at that, and we want you to contemplate the answer, and we take up this question and answer it the next time we meet. Till then, have a good time. Goodbye. Good day. Bye-bye.